we're going to start naming a triangle. All right, I can name a triangle two ways. I can name a triangle based on what I know about its sides or what I know about its angles. So let's first start with what I know about its sides. And now again, this is naming a triangle where I know all three sides and no angles. All right, I know something about all three sides, but I don't know anything about the angles. There are three types of names. What am I telling you in the first diagram here, right here? All three sides are congruent, equal to each other. Anybody want to drop a little knowledge? That's called an equilateral triangle. Yes, if all three sides are the same length, I can call that bad boy an equilateral triangle. All right, equilateral. What if only two are the same length and the third is not the same? What's up, guy? Isosceles. Good. These are great spelling words, too. Just throwing that out there since we have a spelling bee coming up in 2 months. And then what if no sides are the same? All three sides are different lengths. Scalene, yeah. That bad boy's called scalene triangle. Good work, everybody. Good work. All right, so now let's say I know nothing about the sides, but I know all three angles. Or I don't need to know all three angles. I know something about the angles. So let's first start with this one here. All three angles are congruent. Now, could you call that equilateral? You can, because if all three angles are equal, so are the sides. So you could get away with calling it equilateral. A more official name, just knowing all three angles are congruent. Let this roll off your tongue. Equiangular. Equiangular. All right. And can we dive a little deeper here? If all three angles are congruent, they'll all have the same measure. And we can find them that measure. What did you guys tell me about 3 minutes ago about a triangle? All the angles add up to 180. So if all three of them are congruent in an equilateral or equiangular, all the angles have to be 60. Yep. Always. Always. All right, next one. I just threw in 105. You don't need to know about the other two. We're done talking. Anybody remember 105-degree angle? What type of angle that is from Unit 1, Matt? Obtuse. Obtuse. So we call the triangle obtuse. All right. If a triangle has one angle bigger than 90, it's already considered obtuse. Can a triangle have two angles bigger than 90? No. Why not? Because then it would be like it'd be more than 180. So you can only have one angle in a triangle bigger than 90, and that would make it obtuse. You guys are familiar with our friend right here, right? The right triangle. And then finally, the last one, I put 70 and 30 degrees in there. We could find the other angle, all right, just to make sure it's not obtuse. So I have 100 right now. What's the other angle have to be then? 80 degrees. Okay, so none of them are over 90. They're all less than 90. So what do I call those angles that are less than 90? Acute. So I call this an acute triangle. All right. So there are the names we're going to use today. Now I want to mix in some geometry and algebra. How about that? Yep. Geometry and some algebra. All right. A couple things here before we answer this question. M is the midpoint of JL. Let's stop right there. M is the midpoint of JL. Can I have somebody tell me then what two segments are congruent up here? M is the midpoint of JL. One, three. Yeah. What do you have for me? Which two segments? Good. JM and LM. Wait a second. JM and LM. LM was already congruent to KM. So by substitution, I think JM and KM are going to be equal too. All right, good. All right, next thing. Classify. Now, everyone take a look at the notation here. That's how we write a triangle. We name a triangle by its three vertices. Okay, so we are going to try to classify what JKM is. Everyone identify that triangle on your diagram for me, because it's not the big one. JKM, we name a triangle by its vertices. All right, I only know one side right now is 0.75. I need to know the other two sides if I'm going to call it equilateral, isosceles, or scalene. So let's start with JM. Can somebody help me find the length of JM? And look, I gave you JL was 1.5. We just heard that JM and ML are equal. So how about the length of JM? Anybody? Length of JM? 6. Thomas? 0.75. Good, 0.75. I just cut the 1.5 in half. Good. And now how about the length of KM? Well, didn't we just say by substitution JM and KM were equal? So that also is 0.75. So now I think you guys can tell me confidently what type of triangle JKM is. And that would be what type of triangle? Matt?
Equilateral.
Equilateral. Good deal. This is equilateral. And you'll notice the directions do say, explain your reasoning. So why did Matt choose to say that was equilateral versus the other two? So, Amy?
Because all the sides are equal.
Done. I'll use congruent because we use that word a lot. All right, no issues finding those sides and why we're calling it equilateral. All right, second one. Now this is isosceles, and I told you what two sides were equal. I gave you the length of the third side was 9x plus 1. All right, what are the side lengths? Okay, first thing, I just want to eliminate this completely. Please, please. We talked about this number 180 a couple minutes ago. What is the 180 for? What's 180 in a triangle? All the, let's do it again. All the angles in a triangle add up to 180. Not the sides. All right, not the sides. The angles add up to 180. So I am not going to add these three sides and set them equal to 180. No, those are reserved for the angles. Also, I don't need the 9x minus 1 in this equation. All right, just because you were given it, all right, in an algebra, we'll use it. We're going to use it. We need it, but not to find x. All right, so I don't want you guys to feel like you have to use all three sides to set up your equation. You don't. Are we all right on why I just did the equation I put up there? All right, solve it for x for me. Somebody solve it for x, and then we can move on to the rest of the problem. When you're ready, kissing you again, when you're ready, let me know what you get for x. You got it. Thank you. 1.5. Now it said find the sides. So everyone's going to take 1.5, substitute it in for AB, AC, and BC. But we did say this triangle was isosceles. So, hey, two of my answers should be equal here. All right, I should have two side lengths that are the same at the end of this. If not, we got to go back to the calculator and resubstitute. All right, here we go, Doyle. When you're ready, let me know your lengths.
For AB,
Yep.
12.5.
I like that. And then AC and BC, did you get the same lengths?
7.
Darn right you did. 7s. Okay, questions? All right, one more now. Hey, why don't we put a triangle up on a graph now and see what we get? So I'll give you a second. Plot the points. Make sure you write the vertice next to it, the letter D, E, and F, and then make a triangle out of it. All right, got them graphed. All right, what type of triangle is this? Classify it by its sides, right? So at the end, I should have equilateral, isosceles, or scalene, right? Because it's asking me by its sides. And you know how we roll in here. You are not going to be like, oh, that's this type of triangle because it looks like it. No, we got to back that up with some facts. So if I'm going to name it by its sides, I'm going to need to know how long all three sides are. Anything we've used this year that will find the length of all three sides. I think we have something. Back in Unit 1, we have something that will find the length of DF, DE, and FE. Who's digging deep here? Come on. You're killing me right now. Killing me. Yes, please say me. Thank you. Hey, anybody? Distance formula? Yeah? Finds the length of a line segment. There you go. So let's remind ourselves what the distance formula is. I told you guys on the first day of school, we may do it one day, it never goes away, right? It never goes away, these topics. That's what I love about this course. Just because we're done with Unit 1 doesn't mean you're not going to see it again to the midterm. You're going to see it. All right, distance formula. All right, redeem yourself. Anybody remember what's underneath this bad boy? Let's go, Gianna. Let's go.
Is it x like 2 minus x1 squared?
Okay, hold on. Don't forget what you're about to say. Remember, I can do this in any order. Doesn't matter. All right, let's keep going. Come on, finish.
Plus y2 minus y1 squared.
God, thank you for redeeming your class. Thank you. There it is. Yes, order does not matter what you subtract them in. But the x's have to go together and the y's. You can't mix and match them. All right, I'm going to do side DE with you. And then I'm going to let you and your group do the other two sides. All right, so let's find the length of DE. And again, notice how I wrote that DE, no line segment. Because remember, when we get rid of the line segment, it means the length. All right, how about the x coordinates now? X coordinates, D and E. Olivia, x coordinates. Okay, so if I'm going to put it, which is, 2, hey, not minus 5. It's 2 minus a negative 5. Yes, if any of you studs out there want to turn that into plus, that's fine. It's going to be plus 5, but just make sure it's not 2 minus 5. You forgot the negative sign. Squared, and then how about the y coordinates? Ones will 1 minus 9 or 9 minus 1. Again, the order does not matter. That's what's great about distance formula. And you know what also is great? That we can use those good old numworks calculators and it will give me an answer in simplest radical form and decimal. I will always ask you to leave your answer in simplest radical form on a homework or test quiz. So let's continue that right now. So type it all in and let me know. I'll ask somebody in a second what it is in simplest radical form. Once again, Will, when you're ready, simplest radical form. 133? I got the 100 part. 13, thank you. Yeah, so it does a breakdown. That is simplest form. Square root of 113. All right, now it's on you and your groups right now. I'll give you guys 2 minutes to find the distance of FE and DF in simplest radical form. So go ahead. Just when you're done, compare with your group for me. See how we did. How are we looking? All right. Okay, either one. I'll take DF or FE. Doesn't matter. Let me know. Whatever one you're comfortable giving me here first. Ian, go ahead. Which one are you going to give me here?
DF.
Yep. 3 radical 5. Good work. And then anybody have FE? If not, let me know when you're finished with it. 1, 5, Gabby. 2 radical 26 looks good to me. All right, now we have to compare the 3 sides, right? I had DE is square root of 113. DF is 3 radical 5. And FE 2 radical 26. Are any of the sides the same? No, and hey, even if you're concerned, you're like, well, maybe square root of 113 is equal to one of these two. Your calculator gives you the decimal version of all 3. So look at your calculator, look at the decimals, and you'll notice all 3 decimals are considerably different. So none of the sides are the same. So now we can say this triangle DEF is what type? 2. Zoe, what type we got? There you go. Good work. So triangle DEF is scalene. And you know I want some type of justification here. So why did Zoe say it was scalene? Aiden?
Because all the sides are equal.
Done. Because no sides are equal. All good? All right, you guys are going to go right to your Chromebook. Please have a tab open to the textbook pages and a tab open to the answer keys. Okay?